Indeed, I'm going to talk about setting up a network in Europe for large-scale analysis. And I'll be talking indeed about the EHDEN project, which is the IMI project that we started. I'll also be talking about OHDSI, Observational Health Data Sciences and Informatics initiative that started in the US. And we work together very, very closely. Now, my life currently and for a while is actually about this image that you see here. You see on the left patient data in its own source schema. And on the right, you see the aim, that is to extract reliable evidence from that data set. And as we all know, to get to that reliable evidence, there are many, many individual steps and iterations in that pipeline. And for us, it's very important to find approaches to make this whole pipeline very transparent and reproducible to make sure that we can generate reliable evidence throughout this pipeline and have that as a result. And the goal is to do this on multiple databases across Europe and actually at a global scale, because OHDSI is working at a global scale. It's very active in the US, but also in South Korea and China and also in Europe now. And I'll talk a bit about that in my presentation. So the goal is to find ways to do large-scale analysis. Now, what do I mean with large-scale analysis? I mean on many databases, many different types of databases, but also many different types of analysis, and do that for many outcomes. So, for example, I will talk about prediction. That's a working group that I'm leading together with Jenna Raps in OHDSI, where we build a framework for large-scale prediction, meaning that in a cohort of interest, we try to predict many outcomes. So not only one or two, but really a large number, and like to repeat that in many different cohorts. So it's really thinking large-scale, almost brute force. And of course, we want to make these results reliable and think about building pipelines throughout this whole process. Now, the challenge of observational data, and especially doing multi-database studies, is that when we build a tool, like this iron here, and we want to apply it on our data, we see this problem. That we have different adapters, right? I notice it when I travel, this problem. But it's definitely true for data. So data is structured differently. Everybody thinks they can invent the best data model for some reason. I've seen many, many data sources. They all have different structures. Some have redundant tables because that grew over time when they did studies. So we need to find a way to solve that problem, because otherwise we cannot apply the same tools at a large scale. The other problem is that we don't speak the same language. We have different coding systems. So we need to look at both syntactic interoperability, so standardizing the structure, but also semantic interoperability, improving the way we speak our language and have a common terminology system. So to get to the aim of our work, we need to improve interoperability of data. We need to develop tools that allow us to do standardized analytics on top of that data. Of course, we need to have a big data network to get all the results across multiple data sources, different types and geographies. And we need to have a strong community. And we've been investing quite a lot over the last 5-6 years already to build that community of people that have the same ambition and the same view and want to work together on these topics. And I'll show you, I think, some nice results of that endeavor.